our notes for the rest of this chapter. So what I'd like you to do is, in your notes, when you have this red line down the left margin of your page, on the left side, to write SA for surface area. And we're going to look at 3 formulas that deal with surface area. Then I'd like you to skip a line, put volume, and we're going to look at 5 more formulas that deal with volume. Now we're going to do this over the course of the next 8 to 9, 10 days of school. So that we're not going to test all at once. Today we're just going to look at the first formula under surface area, which will be for a rectangular prism. Okay. Now that that's set up, let's take a look at our formula for a rectangular prism. Okay, here is a rectangular prism, again, which is, remember, top and bottom are rectangular. That's what rectangular mean. All the sides around it are also rectangulars. That's what prism means. I've taken my rectangular prism and I broke it into color-coded sections so that you can see the top and bottom a little clearer, the left and right, and the right, and the front and back. As we look at giving you this formula, I think it's important that you understand where these formulas come from or how they're derived. Okay. So first of all, when we're looking at surface area, we're trying to find the area of all of its faces, all the sides, top, bottom, front, back, of this whole thing. So we're trying to look at, first of all, if we can answer these 4 questions, we can then hopefully determine where it is going to be. All right, so let's take a look at question number 1. Question number 1 simply says, how many sides does this figure have total? Well, we can go through and look. We have our top and our bottom. We have the front and this back side, and we have a left and a right. So this has 6 sides to it. Okay, hopefully fairly easy to see. Question 2. Are any of those sides the same as another one of the sides? So when I look at the top, is there any other side that's the same as the top? Well, yeah, the bottom. They kind of partner up. Same with our front and our back. Same with the left and the right. So each side has a matching pair to it. Okay. So if I was trying to find the area of all 6 of these, do I need to find the area of all 6? No, I only need to find the area of half of them, 3 of them. Because the other 3 are the same as the 3 we found. But if we do want all 6, we find those 3. How could we get all 6 then? You take your solution and you double it. You multiply it by 2. So that's going to be our goal, is to find the area of 3 of these faces. The top or bottom, one of those. The front or back, one of those, or the left or right. And then when we get that, we'll double it. Question 3. What shape are the individual sides? Well, all of them are rectangles. Top and bottom rectangles. So rectangular prisms are nice because they're all the exact same shape. Question 4 then, how do you find the area of that type of shape? Well, a lot of students would say the area of a rectangle is simply length times width, which isn't necessarily true. It's really whatever this dimension is here times this dimension. Now, in a rectangle, we usually call that length and width when it's 2-dimensional. When it's 3-dimensional, we actually have other things we use, or other units that we may use also. So let's take a look now at those 3 boxes or 3 rectangular prisms again, where I've now included the dimensions. The dimensions we're going to use is we're going to use length to show how long this box is, the width to show how wide it goes back, how deep the box is, and h for the height to show how high the box is. So those are the 3 dimensions we're going to use. Now when we use those, we've got to look at our specific piece that we want and ask what dimensions make that rectangle. So if I look at just this bottom piece, it's this dimension here times this dimension here. Now to make that a little easier, I can pull that out and we can see that that was the length times the width. So my bottom is length times width, which is also going to be the same as my top. If we look at the front and back, now I've got this dimension. Oh, that looks like length times this dimension. Well, that dimension is the height. And again, if I pull that out, we can see that we have our length and our height for that dimension. And then our last rectangle would be the right side or left, and we'll look at the right. This dimension, which happens to be that. This dimension, which is our, we'll call the height. So again, if we pull that piece out, we can see that that's width times height. Now there's my 3 different rectangles. But that's not what we want. We don't want just the individual 3. We want the total of all these. So if I want the total of all of them, I got to take the area of one plus the area of another plus the area of the third. Okay. But now that's only 3. We still want 6. So once we have that, let me get rid of those, we can then let's double it to find the total solution. Okay. So again, this is my top or bottom piece, my front or back piece, my left or right piece. Those are my 3. Doubling it gives us all 6. Okay. Now there is one thing we want to be careful about when we look at this formula. But first of all, I'll have you write it in your notes. So in your notes where we wrote down those 8 formulas we're going to, this is formula 1, rectangular prism, length times width, plus length times height, plus width times height, times 2. Now you do want to be careful because a lot of times students just plug this all in their calculator, and the calculators, being as smart as they are, follow order of operation, which means they do all those multiplications first before they do the additions. Now, we like that. The only problem is, in that scenario, the only thing that got doubled is that last rectangle. No, I don't want just the last rectangle. I want them all to get doubled. So if we want them all to be doubled, we've got to add them together before we double them, which means before you multiply by 2 at the end, you want to make sure you push the equal sign. Now, you won't see that in the math book. It's just kind of a helpful reminder that as you use your calculator, you want to make sure you understand how your calculator is working. All right, will you please take out a single sheet of paper then? I'll give you pause the video at this point so you can have time to do that. Okay, now that you get a piece of paper out, what I'd like you to do is we're going to go through 2 practice problems together. But for the first problem, I'd like you to write down L, W, and H, because once we have got what these 3 dimensions are, we can then use that formula to find the surface area. But the first thing is to find out what is the length, what is the width, and what is the height. Also, at this point, if you'd like, it may be helpful to write this formula on the top of your page, because as you get to the next problem in your assignment, if you don't have it memorized, you'll have to look at your notes. But if it's right there on the top of your page, it'll be much easier for you to deal with. Okay. All right, let's take a look at the first example then. Now, we've got to, first of all, before we can start plugging numbers into our formula, find out what am I going to put in for my length. What am I going to put in for the width, and what am I going to put in for the height? So you've got to look at your shape. Now, the nice thing about this is, right now I have this as my length. But if I actually turn this thing kind of sideways, then this is the piece that would be in the front. That would be my length. So you go, well, how do I know which way the box should be turned so that I know what the length is and the width and the height is? And the answer to that is, it doesn't matter. You've got 3 dimensions in the problem. You need to find 3 dimensions, and you can make whichever one you want to be whatever you want it to be. If you want the 12 feet to be the length, you use 12. If you want the 6, you use 6, and the 4. As long as you only use each one once, you'll be fine. So let's pick the 12 to be the length. Let's pick the 6 to be our width, and the 4 to be the height. Again, you could have picked those in any order. You're still going to get the same answer. Now, this is where you're simply going to be careful, and you're going to follow through that formula at the top, and every time you see an L, you're going to plug a 12 in for the L's. Anytime you see a W, you're going to plug a 6 in for the W's. Anytime we have an H, we plug a 4 in for the H. Remembering that we're multiplying these, then adding them together, and that we then have to double it at the end. So what I'd like you to do is to take your calculator and carefully go through that problem that you see in the top. Length times width plus length times height plus width times height times 2. Hopefully if you did that, and I'll just do it out quickly, we've got 72 plus 48 plus 24. So 72 and 48 is 120 plus 24 is 144. Once I double that, I get 288. Now 288 is a great answer. Actually, take that back. Is a good answer. It's not a great answer because we do want to, as we mentioned yesterday, the last thing in our notes, we want to include a label. So this should be square feet or feet squared. I like, and I think the easiest way is to use the little 2 for a square unit, remembering that the 2 needs to be way at the end. Okay. All right, I'd like you to try a second one of those. How much cardboard is needed to make this box? So again, if we're looking at cardboard, we're looking at the sides, top, bottom, left, and right. So we're looking at the side, not the space, but the actual box itself. Remember, for your second problem here, to determine what you want your length, your width, and your height to be. Once you know what those three are, then plug them into the formula to find your surface area. If you'd like to pause the video, try this problem, see how well you can do, and then I will give you the solution. Okay. All right, again, it doesn't matter which one you pick to be your length. I could pick the 8.2 to be my length. I could pick the 11 to be my width. I could pick the 2.6 to be my height. As long as you're using those three numbers and you're plugging them correctly into the formula, you should get the same answer. Okay. So length times width plus length times height plus width times height. Don't forget to times it by 2, and you should have gotten an answer of 280.24. These are now inches squared. First of all, if you didn't get that answer, then the only thing I suggest is that you're being much more careful with your calculator, plugging it in. Okay. Number 2, if you had an answer of 140.12, you did everything well, you just forgot to double it. And then the last thing is you do want to make sure that your calculator does follow order of operations. If you're using your own calculator at home, remember, we're assuming that the calculator is doing those multiplication parts and addition parts. So for example, if I wanted length times width plus length times height plus length times height times width, and then we want to double it, order of operations, if you got a good calculator, will do that part first and then add them. If not, it just does it from left to right. It takes length times width, adds the length to it, and then we don't want that. Now, how can you check to see if your calculator is one worth using? Okay. Here's a very simple problem you can plug into your calculator. 1 plus 2 times 3. Now, if you plug that into your calculator and you get an answer of 7, your calculator is a pretty good calculator because it's doing the order of operations. It did that first. If you plug that problem into your calculator and you get an answer of 9, you now know that your calculator just went from left to right and did not follow order of operations. Now, does that mean you can't use that calculator? No, that's okay. It just means that you've got some additional steps you have to take. Let's look back at our formula again. If you're using a calculator that does not follow order of operations, then you'll need to use your calculator to do that problem and write down your answer. Do this, write down the answer, and then multiply this to get your third rectangle. Now that you have your 3 answers, now you'll take your calculator and you can add those 3 together, pushing equals, and then you can double it. Now, is that a lot of extra work? Well, it is some extra work because you got to do 3 separate problems, writing them down, and then adding them up for a 4th problem. Where if you have a calculator that's using order of operations, you can just put it all in, knowing that it's going to do those multiplications first. The assignment today is the same for both classes. However, the only class that has the book for it is the blue book, because it's coming out of the blue book. So if you are in regular math class, it's going to be on page 533, numbers 4 through 11. The green book is going to do a worksheet of that exact same page. Now, if you're in the green book and you don't have your math book, or if you are at home and you don't have your math book, there's 2 options or 2 ways to get this page. Number 1, under the worksheet section of my web page, you could download the web page, or you can also access the blue book from, regardless of what class you're in, you can access the blue book and just go to page 533 also. So you can either download it off my web page or open up the text online and use it that way.